Materials properties for space exploration design structures. Basic factors affecting materials properties for space exploration designs and structures. Planetary and atmospheric conditions like composition, pressure, temperature, surface radiation, winds, ground surface topology. These planetary conditions are also affecting the navigation sequence schedule. In a higher altitude from a planet's surface, there are geomagnetic disturbances, auroras, polarity, fluxes, radiation, reflectance, inclination, vibrations, due entries or re-entries, drag and friction effects, low to high and vice versa, vacuum transitions, oxidation effects, osmotic behavior, pressure drop instances, thermal inertia. As we are approaching our galaxy, avoiding passing directly above the central region, where intensive X-rays and radiation halo exists, we approaching our solar system, entering with positive proximity to the galactic interstellar medium nearby the Orion Spur, with previously mapping for navigation purposes, the relative wind particles around us for safer trajectory to Earth later on. During this course we meet the Voyager 1.
Hello from the children of planet Earth.
On Valentine's Day, 1990, Voyager 1 looked homeward, and what did it find? Not the frame-filling Apollo Earth, but instead that one pixel Earth. That's here. That's home.
The Voyager spacecraft are in the outer layer of the heliosphere, the giant bubble the Sun creates around itself with its supersonic wind. Voyager today is headed for the edge of interstellar space. That's the space between stars, and it's filled with material that has been injected by the explosion of stars, matter which came from a particular direction, creating a wind which has shaped the bubble in which the solar system is surrounded.
Basic factors affecting materials properties for space exploration designs and structures. From low to high orbit and beyond, a spaceship structure can be affected by spaceship velocity at vacuum state condition types, particles density versus vacuum permittivities, electric, magnetic and so forth, electromagnetic fields interactions, excessive charged particles crossing zones, Van Allen, massive solar type storms, partial plasma density variations on surfaces caused by spaceship trajectory velocity or insertion, surfaces electromagnetic interactions, reconnections in various scales, discharges, rapid non-canonical energy transfer allocation, due material malfunction, strong gravitational forces around a supermassive planet or from a star nearby crossing, potential high-speed dust particles encounters greater than 0.5 micron in asteroid fragments, remnants from 5 micron to several centimeters size, spaceship velocity and trajectory conditions on negative proximity, when it is contrary with the interstellar medium flow.
Great magnetic bubble that surrounds the Sun and planets. The heliosphere is the Sun's own magnetic field inflated to gargantuan proportions by the solar wind. Inside lies the solar system, home. Outside lies interstellar space, where no spacecraft has gone before. The heliosphere protects the solar system from these subatomic bullets, deflecting and slowing many of them before they can reach the inner planets.
When our sun sends out an eruption of plasma and energy during a solar storm that hits the Earth, it causes a geomagnetic storm. Those storms can have dramatic effects on the Van Allen belts.
It changes both their size, it usually makes them very big, it pumps them up, and it makes them very, very energetic.
Basic characteristics of properties and requirements to describe material structures. Materials behavior properties in space from NASA missions. Voyager 1 and 2, IBEX, MISSE in ISS materials exposures into space, past probes with old and new rovers platforms on Mars, with a rich array for materials research and with further radiation studies for these interactions with the Van Allen zones where the previous RBSP mission, and now also the MMS mission will help us to broaden our horizon and our learning curve for the behavior of the materials into space. However, as it is pointed to this graph, there is a main knowledge gap concerning the behavior of materials into interstellar space and beyond. We have no other physical scientific probe or current mission for relative materials behavior research outside those current boundaries. Spectrograph on telescopes can measure the medium conditions in a way, not physical interactions with material systems. It is not yet known to which extent materials simulations can close this gap for real. These issues addresses also materials requirements gaps for further investigations.